Hi everyone, in this video we're going to go over 3E, determining transformations. So it's kind of like the opposite of what we did in 3D. So let's just scroll up so you can see what we did. So remember we had the original function, then we had a bunch of transformations. We drew a rough sketch of the original function, but then we'd use mapping to get our new rule. So for 3E, what we're going to be doing is we've got the image of first equation, and all of these I think are basic. Oh no, we've got two at the bottom that aren't. So we'll do them a little bit differently. And then we've got our image. So we're going to use mapping. So we'll kind of do the opposite of what we did in 3D. And then we can state the transformations. Now, when we're looking at mapping the points, and why? Okay, sorry, I'm not plugged in here. Let me just plug you in. All right, can I draw now? Hey, come on. I'm going to draw. There we go. All right, you're already on blue. Okay, so what we do when we're doing our mapping, if we're just looking at the transformations, okay, so because I've experienced, I can see this function and what the transformations are. But we're going to do mapping just because when you get to harder ones, it's not always going to be obvious. Okay, so I'm going to get this in this form here. All right, so just remember we're going to be doing something to that x. So you can have a translation with that x, or you can have a dilation or a reflection. So when you're looking at the transformations, the ease, well, depending on which function you're dealing with, it might be easier to put many things as possible onto the y side and then just dealing with the x in a more simplified way. So I'm going to subtract 3 from both sides. So we're going to have y minus 3. And this is our image. So I'm going to do y dash. So y dash x dash. And I'm also, oops, let's just keep going. I don't want to skip too many steps. All right, so then I'm going to get rid of that 2 by dividing both sides by 2. All right, so what you can see here is I've put things on the left-hand side, okay, and we're going to deal with the y. And then you can see on my denominator, I'm just going to deal with that x. Okay, so I'm going to try to leave the denominator as simple as possible. All right, I'm running out of space here, so I might just go into the mapping of points. So that means y is equal to y dash minus 3 on 2. Remember before we used to get y, and then we used to substitute in for x and y, but now we're going to rearrange and make y the subject, y dash the subject. So to do that, multiply both sides by 2, so 2y plus 3. And we'll do the same with the x's. So x is equal to x dash minus 1. So x dash is equal to x plus 1. So what we've got here is the image of x and y. So x and y, sorry about that, has become x dash plus 1. I was reading the wrong spot. And even though I underlined it, didn't even see it, 2y plus 3. I didn't think I'd have enough space. Look at all that space I've got left. So now we can read the transformations. Now the order of your transformations, we should really do dilations, reflections, then translations. If you're doing something like this, you really need to, the reason we do dilations and reflections first is because if I did translations first, it's going to screw this up unless I had it in brackets. So unless I took that 2 out as a common factor and then dealt with that 3, so that's going to be 3 on 2. Okay, and then then you would read you can read the translation first and then you multiply by 2. But it's a lot easier just to leave it as it is, but if you needed to, you could take out the coefficient of y as a common factor. And then you can read your translation first. Okay, so we're starting, when I wrote DRT, dilation, reflection, translation. So let's do our dilation first. So the 2 in front of the y means it's dilated by a factor of 2 from the x-axis. And then we're going to do our translation. So translated, now just to save time in this video, I'm just going to say to the right 1 and what have we gone up 3. All right, so you'd probably write that in sentences. You wouldn't just use the arrows. Now, for those of you who are familiar with reading transformations from an equation, you can see that's true. All right, let's move on to the next one. So we've got y equals 1 on x squared, so it's a truncus. All right, and we've got a bunch of these transformations. I can already see we've had a dilation of 2 from the x-axis. It's shifted to the left by 4, and it's gone down 7. But let's do our mapping. So first of all, let's rearrange our equations. I'm going to take that 7 over to the left-hand side and then divide by 2, 1 over x plus 4 squared. Now I don't have to do anything with that bracket on the denominator. So let's move on. So that's going to actually be our image. I should put a little dot there. So y is equal to y dash plus 7 on 2. So then y dash is equal to 2 times y minus 7. All right, and then our x's, so x is equal to x dash plus 4. Just thinking, no, we don't need to square that. And what am I doing? X dash equals x minus 4. So we write the dilation, let's do our points first. So xy is becoming to x minus 4 to y minus 7. Okay, so dilated by a factor of 2 from x-axis, and we're being translated. So this time we are going to the left, or in the negative direction of the x-axis by 4, and we're going down 7. All right, the next one, it's written slightly differently. If we just have a look at this denominator, all right, so if you are reading just the transformations from here, you need to actually read it with that negative in front of the x plus 1. So just be careful with that. All right, so let's just do our mapping, because sometimes I think reading it can get a little bit confusing. All right, I just have to concentrate. Y plus 5, and then we're going to divide by 4. And then we have 1 on I'm going to put that, I'm going to put 1 minus x cubed for now. You can take that negative out. So if I took that negative out, I'm going to be left with negative x minus 1. All right, so just remember when we're taking that negative out, the negative x, still got that, and negative 1 gives you the positive 1, so it's going to be cubed. Now, you could take that negative over to the other side and there'll be a dilation from the x-axis, or you can leave it on the side with the x and it'll be a dilation from the y-axis. Now, remember with your cubic, and let's see if I can get Desmos. All right, so we're looking at y equals 1 over x cubed, memory, and we're looking at our transformation. So y equals x. Oops, that was one on. Oh, that was, oh gosh, I can't even remember what it was. Yeah, 1 on x cubed. You can go away. Come down here. X cubed. All right, so let's do our oh gosh. How did you just do that? There we go. Oh, because I pressed that button. Okay, so if I did the negative x there, it is a dilation from the y-axis. But if I took it out the front, it's a dilation from the x-axis, and you can see it's exactly the same. So that negative sign, it doesn't matter whether it stays with the x's or goes over with the y. But the order does matter. So I'll talk about the order when we do our mapping. All right, so I'm going to leave it with the x, just as an example of leaving one with the x. Okay, so y is equal to y dash plus 5. I didn't put the dashes on, but I probably should have. So y dash is equal to 4 times y minus 5. And then our x is negative x dash minus 1. And bring that negative over to the left hand side. Actually, I'll do this in a few goes. All right, over to that side, and then we're left with x minus 1. So x is equal to 1 minus x. Actually, I should put the x first. Negative x plus 1. All right, so our coordinates, x, y, if we're looking at our transformations, negative x plus 1, and then 4y minus 5. All right, so remember we do our dilations first, so it's going to be dilated by a factor of 4 from x-axis. Then we'll do our reflection on that x. Now, you could do the reflection after the translation. All right, it just means you would have to write what we have here differently. So you'd have to take that, I'll just write it here, the negative x out, and you'd have to write it like that. All right, so I'm not going to do that. I'm going to leave it like that. Reflected in the x-axis and translated, so I just write the axes, obviously reflected in an axis, reflected in the y-axis. Remember, it didn't matter if I said x-axis before. Translated, so what do we got? We've got 1 to the right, and we're going down 5. All right, so let's have a look at that one. So we've got 4, let's see if I can remember that. What was the last thing? Was it minus? What was it? Minus 5. Minus 5. Okay, so the red graph is our original graph. Now, if you're looking at a, I don't even know what graph this is. It's kind of like a hyperbola. You can see that your asymptotes are the axes. All right, so we've got asymptotes there. So what we said is it shifted down 5, so you can see your asymptote is there. And we said it had shifted to the right by 1. Let me just check. Yes. All right, so you can hardly see it. It's yeah, we've got an asymptote there at x equals 1, and we've got that reflection there as well. All right, let me just go back. All right, the next two are taken just from basic graphs. So our transformations just come from y equals the cubed root of x. And the next one is y equals 1 over the square root of x. So it doesn't matter how complicated the function is. If it's a basic one, and that means it hasn't had any transformations to the general rule or the basic one, that's fine. But you can see in the last two, for the first one, we're going back to y equals 1 over x. And then the last one, we're going to what have we got? A square root graph that was already transformed, and it's undertaken further transformations. So I strongly encourage you perhaps to do the next two on your own. So perhaps pause the video. I will do them. And then, you can listen to me. I'll just scan ahead and have a look and see how you go. All right, so we're going to start off with just getting it into this form. So we're going to keep the x under our cubed root, but I'm going to take that 2 over. So it's going to be y minus 2 equals negative root, cubed root x plus 1. And I'm going to take that negative over. So I probably should put dashes on there. So when I multiply through by a negative, anything that was positive, so the y was positive, so now it's negative, and that 2 becomes positive. Actually, what I might do, sorry about that, I'm going to put it in brackets. All right, I'm going to put that negative there equals, and then we've got the cubed root of x dash plus 1. All right, so x is x dash plus 1, so x dash equals x minus 1, and then we'll do the y. Was I starting with the y before? Probably was. So y equals negative y dash minus 2. Take that negative over. Actually, I'm going to do this in just one go. All right, so y, what am I doing? Y dash is equal to, so I'll bring that negative over, so it becomes a negative y, and then I'm left with minus 2, so it comes over as plus 2. You'd get the same thing if you didn't put it in brackets, so don't be too concerned about that. All right, so xy becomes, oh, this seems a bit glitchy, my computer, x minus 1, and what is it, negative y plus 2. All right, so my transformations, remember, talk about the dilations and reflections first. So I've had a reflection in the x-axis, so reflected in the x-axis. And we've had 2 translations. So what have we had? We've gone down 1. No, sorry, to the left 1. And we've gone up 2. All right, now if you, just trying to think. All right, so let's just, before we move on, if I wrote the negative y plus 2 with the negative outside, so I wrote it like that, you would need to say the translation and then the reflection. All right, so that's why it's easier just to not have brackets, because you can then always remember dilations, then reflections, and translations at the end. All right, so the next one, let's just do some rearranging. So I'm going to subtract 3 from both sides and then multiply by 2. No, sorry, divide by 2. And then we're left with, no, I should do my dashes, 1 over root negative x dash. All right, now just be careful, you can't take that negative out of that squared root because it is an even power. So, so it's the same as negative x to the power of a half. And I'll just show you, sometimes you can put numbers inside the square roots, but not a negative. So if I just press the wrong button, if I just show you here, so what we've got at the moment is a reflection in the y-axis. If I took that negative out, is going to be a reflection in the x-axis. Now that is different. Now I wonder how to do a cubed root. Cube root? No. Let's get the keyboard. Where is a button that I can use? Do I have a hat? I don't even have a hat. I haven't really used it. Cubed roots. Alright, you know what the cubed root is? Oh, there we go. The cubed root is the same as, oh, you're not in the right spot, dude. To the power of a third. I was just about to do that. Okay, so let's do the cubed root of x, and I'll just change this to be the cubed root as well. Oops. Okay, so we've got two cubed roots now. So if I put the negative there, you've got your reflection in the y-axis. All right, so you can see that. Now, if I took the negative out, same thing. All right, and it has to do with odd and even functions. So remember, an even power, so if you had -2 squared, it'd be -2 times -2, obviously is a positive number. But if you had 2 cubed, or sorry, -2 cubed, -2 times -2 times -2, you're going to have a negative number. So just be careful if you wanted to take that negative out, only do it with powers that are, well, cubed roots. You're probably not going to see anything other than square root or cubed root. Yeah, so the reason I showed you that, let's just go back. So if I had the square root, and I think I've done an example of this before, of x and square root of x. Now, let's say I had a number out the front, so 3. I can actually take that inside and put it inside that square root. Hold on. Yeah. Sorry, it was just turned off before. Okay, so you can do that if you want to. So then you can change it from a dilation from the x-axis. Let me just think. From the x-axis to a dilation from the y-axis, but that gets a little bit complicated. All right, let's stick to what we've got. So now x equals -x dash. So x dash equals -x. And y equals y dash minus 3. Oh, I think I can hear Mr. Whippy. Y dash is equal to 2y plus 3. So our new point is going to become, what is it going to become? -x y minus 3. Reading the wrong thing. 2y plus 3. Okay, so remember we do our dilations first and then our reflections and our translations. Reflections, sometimes it doesn't really matter if you do reflections first, but we're just going to do dilations first. So dilated by 2 from x-axis. We had a reflection, so reflected along y-axis, and then we'll do our translation. So we've only had a translation down by 3. Oh, sorry, why am I saying down? Up, 3. All right, so the next two. Now, you can see my second equation is y equals 1 over x. So I'm going to write the first one in the same format. So like we've been doing, all right, it just happens to be the first equation. So I'm going to bring that 4 over, and then I'm going to divide both sides by 2. So 4 over, get rid of the 2 on the top. You can do this in multiple steps. And then we're left with 1 over 3 minus x. Now, as I said before, it's probably a good idea to take that negative out. So I'm just going to erase that and take that negative out, and I'm going to be left with x minus 3. All right, so basically what I did before is I said x was equal to that, negative x dash, but this time I'm going to say, do my x's first. So negative x minus 3 is equal to x dash. All right, so it's already been done. We don't need to transpose the equation. Or the equation. And then our y, what have we got? Y minus 4 on 2 is equal to y dash. So when I'm looking at my transformations, xy is negative x minus 3. And then we've got y minus 4 on 2. Whoops, about to go through that negative sign. Let's just move that, and you can hardly see that before, so I might just rewrite that again. All right, you can expand that bracket if you like. Let me just think if there's going to be implications for doing so. Now, because we are kind of going backwards, I'm just thinking if we need to do our translations first. All right, I'm going to just expand that bracket. I've thought about it, and I think I might just rewrite our x by expanding that. So we'll have negative x plus 3. That way we can talk about the reflection separate to that translation. And then with the y, actually I probably should have done that. So negative x plus 3. Take out that 1 over 2 as a common factor, because we'll just have the y. And then what do we have? Is it minus 2? Can't think. Actually, still thinking. I'm going to expand that bracket. So we have a half y. Gosh, let's just make that a bit clearer. Okay, so a half y. All right, so I'm separating the two terms on the numerator. So the half y, and then minus 4 over 2, which is just minus 2. All right, we'll write it like that. Okay, so what we've had is, let's do our dilation first. So dilated by half from x-axis. And then we've had a reflection in the y-axis. Then we had a translation. What is that? 3 to the right and 2 down. So let's just have a look at the graph. So 2, 3 minus x. Okay, let's delete you. 2, oh gosh, I can't remember. 3 minus x plus 4. Okay, and the graph we want it to become is 1 over x. And we'll get rid of that keyboard. We don't really need you blocking our view. Okay, so we said what had been shifted down 4. And then it needed to shift to the left 3. And it's also been reflected. Now I'm just wondering about the order of the reflection. So if that was reflected, I don't think it makes any difference if it was reflected first or not. If it was reflected first, then its translation would change. All right, so I wish I could draw on here. Let's make it a bit bigger. All right, so the first equation, y equals 2 over 3 minus x plus 4, and you can see in the red. So if we think about the horizontal asymptote at y equals 4, that's shifted down 4. Actually, we should do the, okay, so we've had a reflection first. All right, so it was reflected. We had a dilation, and then it was shifted down 4, and you can also see that we've had an asymptote at x equals 3, but because it had been reflected first, okay, so it's a bit hard to, let's just draw it. Y equals 1 over negative x. All right, so okay, so if you think about that red graph being reflected first, it would end up with the reflection, it would end up on the other side of the y-axis. So your asymptote, when you reflect it, I might get rid of you, I think that might be a little bit confusing. So let's think about the red graph reflecting, well, the dilation doesn't matter for now, but reflecting first. Our asymptote at the moment is at, and I could probably write that in, x equals 3. All right, so it's there. When we reflect that asymptote becomes negative 3. And to bring that asymptote back to the y-axis, we're going to be shifting to the right 3. So if you can think about it here, we've reflected first and then we went to the right 3. Okay, so if you're wondering why it's hard to explain without. If you're thinking, well, it would shift to the left 3, but it's been reflected. So it's been reflected first and then it has to go back. All right, let's move on to the last one. I think that's the last one. Awesome. Okay, so now it's a little bit more complicated. So we've got to think about, well, what can we do to this to get to what we've got in the second equation? All right, I had to pause to think about this one just a little bit and just to check before I started. So what we want to do is basically what we did before. So if we think about this as just a basic square root graph, so I'm just going to write that down the bottom. So I want to kind of get it in that form just like we've done before, but we're doing it now with 2 equations. So for the first one, I'm going to bring that 3 over, it's minus 3, and then divide through by that 2. And then under the square root sign, I'm just left with 4 minus x. And you can just leave 4 minus x, that's fine. Now with my second equation, I'm going to bring that 6 over. So minus 6 equals negative root x. And I'm going to bring that negative over. So we've got, and I can just leave it like that for now. So negative y minus 6 equals the square root of x. Now, your original, let's do the y's first, y minus 3 on 2 is equal to the image, so negative y dash minus 6. Now, just like we did before, so here, and I won't highlight it because I'm highlighting blue and you might not be able to see it, I need to get y dash on its own. So first of all, I'm going to get rid of that negative sign. So I'm going to multiply both sides by negative. And then I'm going to get rid of that 6, I'm going to add 6. All right, so there's y dash. Now looking at my transformations like that can be, there's nothing wrong with it, but it's probably best to get rid of that bracket like we've been doing. So let's multiply this bracket through by that negative, and at the same time, I'm going to separate the numerator, the 2 terms in the numerator, to 2 separate fractions. So first of all, we'll deal with the y. So I'm going to have y on 2. And then we're going to have negative times negative 3, which is positive. So positive 3 on 2. And then we've got plus 6. All right. Probably not a good idea to have 2 constants. So we're going to put them together. I'll leave that y down the bottom. I'm just going to delete it. All right. So the coefficient of y is 1/2. All right. And then 3 on 2 plus 6. Now 6 as a fraction is 12 on 2. So 3 on 2 plus 12 on 2 gives you 15 on 2. All right, so there's our new image of y. So it looks quite confusing, and this is quite difficult. Let's do the same with x, which won't take up as much space. Okay, so 4 minus x is becoming x dash, and because now I have x dash on its own, good, don't need to do anything. So my image of my points, which might help, you can leave them there because we're just looking at the transformations, but let's just write them. So we've got 4 minus x, just write the x first, so negative x plus 4. And then we will do the y. So it's a bit hard to see. Might just, oh no, I'll write it down here. Negative a half y plus 15 on 2. All right, so it was quite complicated with what we did with the y, and you need to also realize that you can have different combination of transformations. Okay, so what I am doing here could be different to what you've done. It doesn't mean that I'm right or wrong, and it doesn't mean that you're right or wrong. We're just saying, all right, there's a different way that you can get from A to B. Okay. All right, so let's start with the dilations first. So we're dilated by 1/2, and you can see that by the coefficient of y from x-axis. Then we've got 2 reflections. So we've had a reflection in the x-axis and a reflection in the y-axis. So reflected in x-axis and y-axis. And I have explained that, I think, in a previous video, how you can have both. And then we've got a translation. So we've got translated 4 units in the positive direction of the x-axis. So we've gone to the right 4, and we've gone up 15 on 2, or if you like, 7.5. All right, so that's probably as hard as it's going to get in this section. Thanks for listening, girls. Bye.